Alright, in this section, we are going to do a really brief introduction to multiplying matrices. I'm going to show you quickly how to multiply matrices, and I'm mostly doing that so we can determine what types of matrices can be multiplied together. So, to multiply matrices, you must do what we call the dot product. So, dot product of each row of the first matrix times the column of the second matrix. So, what that'll look like here is you will multiply this row by this column, and that will give you this first part right here. And so, you can see you do A11 times B11 plus A12 times B21, and then A13 times B31. Now I'll give you this first spot here. Once you've done that row times that column, you will erase this so it'll show up. You will need to do, let me use a different color, you will need to do the first row times the second column, and that will give you the second place here. So you have A11 times B12, A12 times B22, and A13 times B32, and that goes in the spot here. After you do that, you got to go to that second row. So you would do the second row times the first column. That'll give you this piece here. And then lastly, you would do this second row times that second column, which will give you this one here. So I'm going to do an example of what this would look like with some actual numbers, and then we will look at what types of matrices can be put together. So, for example, if I wanted to multiply this together, I would start off with this row times this column, and that's going to give me a number here. So, I'll put my matrix here. And so what I'm doing is I'm doing 3 times 6, 3 times 6, plus 4 times negative 1, 4 times negative 1, plus 0 times 0. So that's going to give me 18 minus 4, which is going to give me 14. So that's going to go right here in my matrix. So once I've done that, I got to do the next section, which is going to be the first row times the second column, and that will go here. So that would look like this. We'll have 3 times 2 plus 4 times 4 plus 0 times 3. So first one in each row slash column, and the second one's multiplied together, then the third ones are multiplied together. So we get 6 plus 16 plus 0, which of course is going to give us 22. So we have 22 right here. Then we need to go down to the second rows. So there's this here. For that second row, we're doing the second row times the first column. And so we're going to do 2 times 6 plus negative 5 times negative 1 plus 6 times 0. So that's 12 plus 5 plus 0, so 17. And that is going to go right here. There we go. Right here in our matrix. So we'll have 17 right here. And then for our last one, we will be doing the bottom row and the last column, and that answer will go right here. And so for that, we would have 2 times 2 plus negative 5 times 4 plus 6 times 3. So 4 minus 20 plus 18 is going to give us negative 16 plus 18. We'll get 2 for that, so we'll have a 2 right there. And so this would be our answer. So, because of the way matrix multiplication is done, you can only multiply certain matrices together. In order to multiply two matrices, the number of columns of the first matrix must equal the number of rows of the second matrix. So I sort of think of it like this. If we were writing the order of a matrix, which we did yesterday, then the order of this matrix, we've got 2 rows and 3 columns. So this is a 2 by 3 matrix. The order of the second matrix is a 3 by 2 matrix. So the columns of the first matrix have to match the rows of the second matrix. And if they do, then your product is going to be a 2 by 2 matrix in this case. So you got the number of rows of the first matrix and the number of columns of the second matrix. So down here I have a matrix of order C times D can be multiplied by a matrix of order D times E. The product of the matrix with order, the product will be a matrix with order C, E here. So for each one of these, we just need to look at them and tell if they can be multiplied together, and if they can, we're supposed to give the order of their product. So this first matrix, we have a 2 by 2 matrix, and the second matrix, we have a 2 by 3 matrix. So we can see that the columns of the first matrix match the rows of the second matrix. So our product, so this will be a yes, and our product would be a 2 by 3 matrix. And we get that 2 by 3 by looking at the rows of the first matrix and the columns of the second matrix. Our second one, this is a 4 by 1 matrix, and the second one is a 2 by 4 matrix. And so you can see here that these two do not match. So since they do not match, then this would be a no. What's kind of interesting here is if we switched the order of these two matrices, if we put this one first, then we'd have a 4 by 2 and 2 by 4 and a 4 by 1, and we could actually multiply those together. So you'll find that matrix multiplication is not a commutative operation. You cannot switch the order. So taking matrix A and multiplying it by matrix B is not going to be the same as multiplying B by A. All right. For number 3, this is kind of an easy one because you got 2 by 2 and a 2 by 2. Clearly these two right here match. So you're going to get a yes. And this is 2 by 2 matrix is what you're going to end up with here. For number 4, you're going to have a 2 by 3 matrix, and you have a 4 by 2 matrix. Here, the 3 and the 4, they do not match, so this one would be a no. For the 5th one, we've got a 3 by 3 matrix, and then we've got a 3 by 2 matrix. Remember, always rows first, then columns. So the columns of the first matrix match the rows of the second matrix. So yes, we can multiply these together. Our product would be a 3 by 2 matrix. And for our last one, it really seems like we should say yes to this because our matrices are the same, but a 2 by 3 matrix and a 2 by 3 matrix, notice the columns of my first matrix do not match the rows of my first matrix. These two matrices can be added together, but they cannot be multiplied, so this one would be a no here. So your delta math is going to look like this. You can see here, this is a problem like we just said. You got a 2 by 3 times a 2 by 3, which is going to be undefined. So if it says undefined, you won't give an order of your answer. And so like here, is throwing in some adding and subtracting. Here you're subtracting two matrices that are the same size, so your operation is defined, and you've got a 4 by 4 matrix here, so 4 by 4 is going to be your answer. Here we're multiplying. You've got a 5 by 2 times a 5 by 2. That is not going to work. It's going to be undefined. Adding here, to add and subtract matrices like we talked about the other day, you have to have the same dimensions. So this one's going to be undefined. Here we have a 3 by 4 and a 3 by 3. That 4 does not match the 3, so this one's undefined. Here we have a 3 by 2 and a 3 by 2, still going to be undefined. Let's try to find one that is actually defined, but I'm going to get a lot here. 5 by 3 and a 3 by 1. Here's one that will work, because I've got 5 by 3 and then 3 by 1, so this one will work. So if I have a 5 by 3 and a 3 by 1, my result is going to be a 5 by 1. And so you'll just do this for these problems. If you have any questions, let me know.